The process of navigating the World Wide Web is fairly familiar for most people that use computers on a daily basis. This process is characterized by a user scanning the computer screen with his or her gaze, looking for information of interest and scrolling down or up the page to display additional content. When a user finds a link of interest, he or she initiates a manual action with the mouse to acquire it. At this point, a server-client model of interaction is used to provide the user with the requested information. Within this computing model, the web browser acts as the client that requests information to a web server that in turn provides the corresponding information to the client. Most Internet users are familiar with the elapsed time that occurs between them clicking on a link of interest and the corresponding information being actually displayed on a screen by the web browser. This latency is the result of the amount of time required by the different layers forming the IPv4 protocol to connect, handshake, transmit, and verify the data integrity involved in the communication. This latency is common to all sorts of web browsing activities. Using the information provided by an eye tracker can reduce significantly the latency involved to display web content during web browsing. This can speed up task completion and user comfort. A video-based eye tracker is a device that uses a camera to monitor the eyes and a set of infrared LEDs to create a pattern of reflections on the surface of the cornea. After a calibration procedure consisting of looking at a number of points on the screen, the device is able to infer the area of the screen at which a user is looking. In this video, we illustrate the data provided by the gaze estimation algorithms using a transparent red dot superimposed on the web browser interface. This red dot indicates the area on the screen at which a user is looking. You will easily notice that independently of the web browsing task at hand, the user's gaze hovers over a link before he or she actually clicks on it. This happens independently of whether the user is looking at a video on YouTube, reading the news, looking for an image with a specific characteristic, or searching for information with a search engine. The amount of time that elapses since looking on the link until the user clicks on it varies, however, depending on the task at hand and the user's search strategy and gaze patterns behavior. A prefetching system takes advantage of this information about gaze behavior to prefetch in advance those links visited by gaze and downloading the corresponding information behind the scenes using hidden tabs of a web browser. When the user finally clicks one of the links previously prefetched, the information is displayed by the browser instantly since it has been already downloaded. The increase in web browsing speed and user comfort can be significant for several types of web browsing tasks. Notice the user's gaze in these specific examples of the prefetching system at work. The gaze behavior shows that the user is looking at different links before deciding on clicking on a specific one. Since the link where the user finally clicks was already hovered by gaze before, the prefetching system already downloaded the corresponding web content, and it is able to display it instantly when the user clicks on it. We show next several examples of the prefetching concept in several web browsing tasks. Obviously, for a real application, the transparent red dot indicative of gaze is not present in the display since it can be distracting for the user. In this part of the video, you can see how the system looks like when working without the transparent red circle indicative of gaze direction. Notice how fast information is displayed to the user when he or she clicks on a hyperlink of interest. Statistics about the different hyperlinks where the user looks at, the time to complete the download, the data size of each web page prefetched, the actual hyperlinks where the user clicks on, and the time gained to display by using prefetching are being collected in an Excel table by the prefetching system for subsequent data analysis. This concludes this demonstration video about the advantages of a prefetching system that uses gaze data information in real time to prefetch in advance web content of potential future interest to the user in order to increase navigation speed and user comfort. We hope that you have found this video good enough to illustrate the concept. Thank you very much for your attention.